So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AQA GCSE Maths of 2022 with a focus on the Foundation Paper 2, looking at the numbers section revision list. Now there will be a copy of the questions as always in the description below for you to download and have an attempt at either before watching this video or while watching this video and going through the answers. So looking at these topics from the number section of paper 2 on the foundation paper, I have to say that I can't see many of these questions being big mark questions. The only possible exceptions of that is going to be order of operations, which is basically bid mass. The number problems could be anything, and I would say maybe the fractions could come up as a more than a 1 mark or a 2 mark question. Everything else, I would say, would not be surprised if many of these come up in the early parts of the paper, if not the very first 2 pages where you tend to have more multiple choice questions. So breaking this down, in terms of the first one, order of operations, you're basically looking at bid mass. So here you may be a case of where you need to show a calculation. Now with it being on the calculator paper, you can easily just type in these questions on your calculator, press equals, and jobs are good in. The other thing that you could have is where you've got to input brackets to make certain questions true. You could also have questions where someone has made a mistake and you need to spot the mistake either because they've used bid mass incorrectly. Now in terms of fractions of a number, so again here, what we're looking at is A over B of, let's say, C. You could have a question where you have to write a fraction. So for example, I've seen previous questions where it says, write 21 as a fraction of 6, or something along those lines. Now when it comes to improper fractions, again, dealing with those, so being able to work with converting to and from mixed numbers could come into play. And then you've got fractions to decimals, so that's just basic conversions of fractions and decimals and percentages, etc. Number line decimals, again filling in empty blanks, again should be the start of a question because that's quite low level. Number problem could be absolutely anything in terms of that. Either you could be potentially using money, but I think if money was going to be on this paper then it would come up. But again, money is one of those types of questions where it can appear in anything, so it's just mindful of being with that. Prime numbers, cube numbers, in terms of recognizing what prime numbers are, and again it's expected that you know your prime numbers up to 50 at foundation level. Cube numbers, knowing all your cube numbers up to, let's say, 6, and then knowing what 10 cubed is. Decimal places, that's going to include potentially looking at rounding and estimating. And then inequality notation, it's just a case of knowing when to use less than, when to use more than, and when to use the equal signs as well towards of those. So hopefully when we look at some example questions, a lot of these topics will come into play as to when we actually need to use them. Now before we get started on some of these questions, just a little reminder that you can download these questions by clicking on the link in the description below, and you can either have an attempt at these questions either before continuing watching this video, or you can have a go while watching this video. So looking at question 1, we're looking at order of operations. So in this question it says that C equals, and then we've got 250 minus 16 squared, D equals 18 times 14 all over minus 28, and we want to work out the value of C times D. Now this is on the calculator paper, so you've got a choice and it is worth 2 marks. So here I would say you would get 2 marks if you get the correct answer. Now there's a couple of ways in which you could do this. You could either work it out separately, so if I do 250 minus 16 squared on the calculator, I end up with an answer of minus 6. If I then perform this fractional calculation of 18 times 14 all divided by minus 28, I get an answer of minus 9. So here, to work out C times D, I'm going to do minus 6 times minus 9, which is going to be minus 54. Well, actually positive 54, I should say. Now, if I wanted to, I could easily have just typed that all into my calculator using my calculator correctly. So let me just show you how I would do this. So I'll probably put it in brackets actually. So 250 minus 16 squared, close bracket. And then we've got to multiply that, then opening the second bracket using the fraction button, 18 times 14, and then scroll down to minus 28, then scroll across to close the bracket, press equals, and we get the exact same answer, so 54. Moving on to question 2, it says make the following calculations true. So we just need to use plus and minuses and brackets where possible. So here I want to end up with -4, and again this could either take you a couple of seconds or it could take you a couple of minutes, but I would say try not to spend more than 3 minutes working at this question at its first attempt. So here, now again, there are several combinations you could have for where you put the correct brackets, what signs to put. I'm just going to give an example of one possible set of answers. But again, if you look at the mark scheme on the attachment, on the document attached, you'll be able to see whether your answer is good enough to get the full marks. So here I'm going to add these 3 numbers together and then take away 7. To get 0, all I'm going to do here is do 2 times 0, which is going to give me 0 times, and then I could do absolutely anything I want in that second bracket. Then to get 2 to the power of 4, now 2 to the power of 4 is 16. So here I'm going to do 1 plus 7 and then 2 plus 0 and multiply the 2 numbers together. Now again, that is just one simple example of where you could possibly get your 3 marks from. Moving on to question 3, again, very, very similar. So it says here are 2 calculations and we've got it true. So what we need to do then is use 2 for the next one. So here I want to get an answer of 2. So I can do that by doing 4 times 4, which is 16, divided by, and then I want to try and get 8. So I've got 4 plus 4, which gives me 2. Then to try and get 3, I'm going to do 4 plus 4 plus 4, which is 12, divided by 4 gives me 3. Moving on to question 4. So again, it says in this question you may only use the plus and the times symbols, and it says put signs in each calculation so that the answer is a multiple of 5. So again, really important that we understand that here the answers have got to be multiples of 5. So it's got to either end in a 5 or end in a 0. So from this, what we're then going to do is, again, so I could do 1 plus 3 and take away, actually let's not do take away. So that's going to give me 3. 3 plus 3 gives me 6, and then plus 4 gives me 10. Then think of another combination. So let's go for 3 times 2. No, let's go for 3 times 2, which is 2, and then plus 3, which gives me 5, and then 5 times 4, which gives me 20. And I think I should be able to use brackets, and that gives me 20. And then for the next one, let's go for 3 plus 4, which is 7, times 2, which is 14, plus 1. So let me just put that in brackets, like so, and that should equal 7. That should give me 15. Moving on to question 5. So again, dealing with order of operations. So it says use 3 of the cards to make the following complete. So here we've got to try and make 8. So let's go for 4 times 2, which is 8, plus 1. Then use 4 of the cards to make the sum complete. So here let's go for 3. We're going to take away. So let's do 3 times 4, which is 12. And 12 take away 5, so let's use 5 and 1, and that gives us 7. And it says use all 5 cards to make the following. So here what I'm going to go for is, and I'm going to go for 3, 4, 5. So 3 plus 4 is 7, plus 5 is 12, and there I've used all the 5 cards. Moving on to question 6, so this is where we move on to fractions. So it says work out 21 as a fraction of 12. So here I'm going to do 21 over 12, and then so simply find simplify the fraction. So find a common factor that goes into both 21 and 12, which is going to be 3. So I've got 7 over 4, which is my first option. Then with question 7, it says, as a decimal, 11 over 40 is 0.275. Work out 33 over 400. So what I want to try and do is get 11 over 40 and try and get that to 33 over 400. So for this, what I need to do is I need to multiply by 3. And this, I then need to multiply by 10. So from this, let's first of all here, looking at the top number, I'm going to do 0.275 times 3, which again, I can just use my calculator for that. So 275 times 3 is 0.825. And then all I then need to do is 0.825 divided by 10. Which by that, all I need to do is move the decimal point one place. So I get 0.825. Then moving on to question 8, it says circle the fraction that is equal to 2 1/4. So here all I need to do is just convert this into a mixed number. So I'm going to do 2 times 4, which is 8, plus 1, which is 9. So it's 9 over 4, which is my second option. With question 9, it says convert 47 over 8 into a mixed number. So here all I need to do is do 8 over 47. How many 8s go into 4? 0. How many 8s go into 47? That's going to be, it's going to be 5. And remainder 7. So it's 5 and 7/8. Then with question B, it says convert 61 over 128 and into a decimal. So for this, all you need to do is just simply stick this into your calculator and it should equal 0.4765625. I'm going to round it to 2 decimal places. So then it becomes 0.48. Moving on to question 10, it says the average age of teachers in a school is 36 years old. Mr. Smith's age is 11 over 9 of the average. How old is Mr. Smith? So all I need to do here is 11 over 9 multiplied by 36. So again, going straight into my calculator, 11 divided by 9 multiplied by 36, and it gives me an answer of 44. Then moving on to question 11, so this is looking at number lines, and it says which is the value of A. So looking at this, what I want to do is see how many points there are that goes up between 3 and 1. So here I've got 1, 2, 3, 4, 5. So here I'm going to do 1 divided by 5, which is 0.2. So it's going up in 0.2. So this is going to be 3.2. This is going to be 3.4, 3.6. 3.8. So what's the value of A? Well, it's going to be 3.6. Then with question 12, it says write down all the prime numbers between 40 and 50. So here we're looking at 41, 43, 47, and that should be it. Now again, if you're ever unsure, I would start by actually writing down all the necessary numbers. And then sometimes it may be just a case of going through and seeing if it does work in terms of that. Another way you could do is if you've got a fact button on your calculator, especially if you've got a Casio one, just enter the number, press equals, press shift and fact. If it comes out as the same number, then it's a prime number. Moving on to question 13, it says A and B are both prime numbers. They are each less than 20. Give an example where A plus B is odd but not prime. So here, all the prime numbers between that are less than 20. So we're looking at not 1. That's a definite faux pas there. And so here we're going for 2, 3, 5, 7, 11, 13, 17, and 19. So they're all the prime numbers that are between between less than 20. So here all we need to do is add to any of these two numbers up and show that it's odd but not prime. So here I'm going to be going for, now because I want it to end in an odd number, then I'm going to be definitely using the 2. So 2 plus 3 is 5 and 5's prime. 2 plus 5 is 7, that's prime. 2 plus 7 is 9 and that's not prime. So that would be one example. Then moving on to question 14, it says, I'm thinking of a prime number. Its digits add up to a square number. Write down the prime number that I could be thinking of. So again, all you want to do is think of a prime number and its digits add up to make a square number. Now I'm going to go on a limb and say that it's going to be a 2-digit number. So here, if I've got 13, which is a prime number, and I do 1 plus 3, which is 4, 4 is a prime square number. So again, the prime number you're thinking of potentially could be 13. And then there could be several other answers you may have for question 14, and again, it's worth just looking at the mark scheme. For question 15, it says Zoe's password is made up from 4 different digits. She remembers it as 2-digit numbers. The first 2-digit numbers is a prime number between 10 and 20. The second 2-digit number is a prime number between 20 and 30. List all the possible passwords. So for this, let's just label this as blue and label this as green. So in terms of the first section, we want all the prime numbers that are between 10 and 20. So here I've got 11, 13, 17 and 19. And then in terms of the prime numbers between 20 and 30, we're looking at 23, we're looking at 29, and that's pretty much it. So then from this, what we then got to do is work out the possible combinations. So I could have 11, 1, 1, 2, 3 and 1, 1, 2, 9. I could also have 13, 2, 3 and 13, 2, 9. I could also have 17 and 2, 3 and 17 and 2, 9 and 19, 2, 3 and 19, 2, 9. So it's 8 possible combinations that I'd be writing down. So looking at question 16, it says circle the number that is 1 less than a cube number. So all I need to do here is add 1 to each of these numbers and see which one is a cube number. So this is going to be 21, 23, 25 and 27. Now because it's a cube number, we're looking at 1 cubed, which is 1, 2 cubed, which is 8, 3 cubed, which is 27, and there we have our winner. For question 27, it says write down a even whole number that is also a square number. So here, what we're looking for is, we could have 4. So again, there's going to be several other combinations you could have. So you could have 4, you could have 16, you could have 36, could absolutely anything. There's loads of combinations you could potentially have. Could even have 10 or 100. Sorry, 10 squared, which is 100. Next one then says write down all the cube numbers between 100 and 400. Now for this, I would strongly recommend that you get your calculator. So here, in terms of cube numbers, well, we know that 4 cubed is 64, 5 cubed is the first one. So if I do 5 cubed, I get 125. So I'm writing 125. I then go for 6 cubed. So 6 cubed, which is 216. I then go for 7 cubed, which is 343. I then go for 8 cubed, which is 512. 9 cubed, which is 729. And you can see here that I've not read the question, so we're looking for ones between 100 and 400. So we're looking at just these 3. So it's 125, 216, and 343. Moving on to question 19, it says which 2 numbers when added together make a cube number? So 1 plus 8 gives me 9, so that's not it. 2 plus 4, which is 6, that's not it. 9 plus 18, which is 27. And again, we have our winner. For question 20, it says what is 6.2819 to 2 decimal places? So it's going to be 6.28, which is our last option. Then for question 21, it says Oscar and Eric want to find out who can solve puzzles faster. They each solve 5 puzzles. Here are Oscar's times in seconds. Eric has a mean time of 10.31 seconds. Who has a lower mean time? So what we need to do is work out the average or the mean of these 5 numbers. So if I then add them all up and then divide it by 5. So let's get the calculator back out. So here I've got 10.03 plus 9.78 plus 10.61 plus 12.9 plus 10.08 and press equals, and that comes up to a total sum of 553.4. I'm going to divide that by 5, giving me a Oscar's average as being 10.68. So who has a lower mean? Eric has a lower mean, and that's because 10.31 is less than 10.68. Moving on to that, it then says they decide not to use their slowest and fastest times. The winner is the one with the lower mean of the other 3 times. Eric's new mean is 0.34 seconds more than before. Who wins? You must show you're working out. So for this, Eric's mean is going to be 10.31 plus 0.34, which gives him an average of 10.65 seconds. So then what we then need to do is work out what Oscar's is going to be. Now we're going to lose the slowest time, which is 12.9, and we're going to lose the fastest time, which is 9.78. So here what we've got is we've got Oscar's mean is going to be 10.03 plus 10.61 plus 10.08, all divided by 3. And again, if I just quickly work that out on the calculator, 10.03 plus 10.61 plus 10.08, that comes up to a total of 3072 divided by 3, which gives him a time of 10.24 seconds. So who has a quicker mean? Well, it's going to be Oscar. So Oscar wins. The next question then says write down the integer values of x where x is between that. So if I write down all the numbers between these two numbers inclusive. Now if it's got a line underneath it, means that you can include it. If it doesn't, you need to get rid of it. So I get rid of the 7. So it can either be 1, 2, 3, 4, 5, 6. Moving on to question 23, it says x is greater than 5 and less than 9, or less or equal to 9. Which inequality is this going to be? Well, it's going to be our last option. Question 24 says circle the correct statement. So is -4 less than -3? Yes, it is. And we'll just double check to make sure, even though it's only worth 1 mark. So the second statement is false, the third statement is false, and the last statement is also false.